on these sites. First, we will go into simultaneous observations. Simultaneous means both the observations are taken at the same time, and then we will move on to staggered observation. Staggered observation means observations are taken with a time interval, time gap in between. So that's the plan. So ready beta, shall we start off? In this presentation, we are going to learn about the plotting of sites. It is also known as graphical combination of sites and is also known by the name of staggered observations and simultaneous observations. All these names meaning the same thing. Let us now try to understand what this actually is. In celestial navigation, we have worked upon celestial sites, celestial observations, using different bodies, sun, stars, planets, and moon. We have used different methods depending upon the situation, like meridian passage, latitude by meridian altitude, long by Crone, intercept, X meridian, and Polaris. Now, all these methods have given us position lines. If we take one celestial observation or if we take one celestial site, we can obtain one position line for that time. Now, the ultimate aim of the navigator is to fix the vessel's position. So, the ultimate result which we want from this exercise of site taking or observations is that we should be able to fix up the position of the ship. If we have a position line, it just signifies that the vessel's position lies somewhere on that position line. It does not tell us where is the vessel right now. It could be the position line, could be running in dangerous waters, it could be running in safe waters also. So just knowing a single position line does not help the navigator much. What we are ultimately interested in is getting the position of the vessel or getting a fix. Now, for getting a fix, we need to have minimum 2 position lines. If we have 2 such position lines, then we know that wherever these position lines intersect will be our position. So this is our ultimate objective for site taking, that we should be able to obtain at least 2 PLs, and combining those 2 PLs we should be able to get the position of the ship. Now, for obtaining 2 position lines, we need to work at least 2 astronomical sites. One observation gives us 1 PL, the second observation gives us the second position line, and once we have these 2 PLs, we can plot them on the chart or on our plot, and wherever these 2 lines intersect will be the position of the ship. Now, it is possible that 2 celestial bodies may be available to us at a particular time. So in that case, the site can be taken for both these bodies at the same time. And if 2 sites are taken at the same time, it is known as a simultaneous observation. Now, in some other situations, it is possible that there may be only one celestial body available to us at a particular time. Let us say, for example, you want to take a site during daytime. The only body which may be available at that time could be the sun. Now, with no other celestial body available, it is not possible to take a simultaneous site. You cannot take 2 sites at a single time. So what can be done in those scenarios is, You can take one single side of the body and then wait for some time, let the sun move a little bit in the sky to another location, and after some time you use the same body to take the sight again. Now after some time, when you take the sight again, you get a different position line. So now in this case we have two position lines for different times. These can also be combined and can be used to get the fix of the ship. This type of observation is known as a staggered observation. If sights are taken at different times, then they have to be transferred to a single time. While transferring, we have to allow for the vessel's speed and course, and if there is any external factor like wind or current, they also have to be taken into account and the position line transferred. Now this kind of observation is known as a staggered observation. Usually on board a ship, when we take sights and we plot them, we are able to plot them on the chart. We have the chart of that particular area available to us. We can plot the position lines on the chart, and once they are there, whichever position they intersect, its latitude and longitude can be read off from the chart, and we have the vessel's position known to us. But in our paper, the plotting questions, staggered or simultaneous plot or graphical combination of sights question, may come in the practical navigation part. It may not come under the chart work part. So usually it appears as question number 5 or 6 of our paper, and it does not relate to the chart which is given to us. Means you will not be able to plot these sights, plot these position lines on the chart. So how do we get our position now? We have to construct a small part of the Mercator chart on our answer sheet. It can be done on a plain paper on our answer sheet, or sometimes they provide us with a graph paper. It can be done on the graph paper. The graph paper gives us a little bit of advantage. It has parallel lines and perpendicular lines, which we can use to draw our latitudes and longitudes. So otherwise the procedure can be done on plain paper as well as on graph paper. Now this procedure of constructing a small part of the Mercator chart on our answer sheet or on the graph and plotting 2 or more position lines to get the vessel's position is what we know as plotting of sights. So this is our ultimate aim now for plotting of sights. Now when we plot the sights, we are provided with information which we obtain from a observation. We have seen different observations: Marpas, Long Bicron, Intercept, X Meridian and Polaris. Now whatever information we obtain as answer from these sights by working out these sights, that is basically a reference position from where the PL passes and the direction of the PL. These are the two information which we get from working out a sight. This is provided to us in the plotting questions. So we have the sight worked out and its information given to us, and we need to plot it on our answer sheet or the graph paper and find out the fix of the ship. Now before we go into the actual procedure of plotting, let us refresh some features of Mercator charts so that we are clear about how to make a small portion of this chart on our answer sheet. Now on a Mercator chart, all the meridians are parallel and 1 nautical mile is equal to 1 minute of latitude. The distances are measured in nautical miles. Or in other words, you can see that the scale of distance is same as the scale of latitude. The north-south distance measured on a Mercator chart in nautical miles is equal to the minutes of d-lat between the two places. The east-west distance between two places measured along the latitude scale gives you the departure between them in nautical miles. If you measure the east-west distance between two places along the longitude scale, it will give you the d-long. But if you measure the east-west distance between two places along the latitude scale, it will give you the departure between them in nautical miles. So these were some features of the Mercator chart, which will help us in constructing a small part of it on our answer sheet. Now, as we have seen that on a Mercator chart, the east-west distance is the departure between two places. Now, when we make a small part of the Mercator chart on our answer sheet, you see on an actual Mercator chart, there are two different scales. We have the latitude scale and we have the longitude scale. Both of them are different from each other. That means 1 minute of latitude will be different from 1 minute of longitude. Now, if we are making a small part of the Mercator chart on our answer sheet, it will be very complicated and time-taking to make a chart having two different scales. So in our chart, in our plot, we do not use two scales, we only use one scale, and that scale is the latitude scale. Now, if we have only one scale on our plot, then you have to measure all the distances, whether they are in the north-south orientation or the east-west orientation on the latitude scale itself. The north-south distance measured along the latitude scale is the d-lat, but the east-west distance measured along the latitude scale is the departure. So we need to make sure that whenever we have to show a east-west distance on our plot, we have to show that distance as departure, not as d-long, because in our plotting, we do not use the longitude scale at all. So for putting any information or position on our plot, we will use the east-west distance as departure. Now, how to get the departure? Departure is obtained from the parallel sailing formula, which is departure is equal to d long into cos of m lat. M lat is the mean latitude. So whenever you want to put or feed or show the east-west distance on our plot, we will calculate the departure and then use it to show that particular distance on our plot. Likewise, when we are reading off any distance, east-west distance from our plot, we will always get the departure and we will have to convert it to d long using the same formula. Any east-west distance entered in the plot should be the departure, and any east-west distance picked up from the plot should be the departure. It should be converted to d long for our use. Any doubts up to here, beta? Great, beta. Very good. Now going a little further in plotting, the plotting can be done on plain paper or if possible graph paper. Whatever plot you do, it should be based on a certain scale. To give you an example, the scale could be 1 centimeter is equal to 1 nautical mile, or if required, it could be 1 centimeter is equal to 2 nautical miles. Whatever scale you select, it should be clearly mentioned in the plot. Without the scale, the plot is meaningless and it is a very important items to be shown in the plot. Most convenient scales to use are 1 centimeter is equal to 1 mile, or if the diagram is not fitting on our answer sheet, the plot is big, then it can be made smaller by taking a scale 1 centimeter is equal to 2 nautical miles. Most of the questions you will be able to solve using these two scales. Now, even if you have to use a bigger scale for some question, avoid putting any fractions in the scale. Avoid taking 1 centimeter is equal to 1.5 mile or so. So fractions in scale will lead to errors. It will become difficult and time taking to convert the values, plot values to actual values. So fractions should be avoided. Now in staggered plotting questions, we need to transfer a position line. Now the position line can be transferred using two different methods. Either the PL can be transferred by applying the course and the distance steamed by the vessel to any point on the position line. The first method is you can straightaway apply the course and distance on the position line, any point on the PL. You reach to a new point and you draw a line parallel to the initial PL and the PL is transferred. Now the second method is using calculation. So in calculation, we pick up any point on the initial PL, apply plane and parallel sailing to it and find out the position arrived after a certain course and distance has been applied to it. So this is the calculation method. We can calculate the new point or the new reference position from where the transferred PL will be passing. Now, which of these two methods should be used in a particular question? If the distances involved are less than 10 miles, you can directly apply the course and distance geometrically using the plotting tools. But if the distance exceeds 10 miles, then you should prefer using the calculation method. A reason for this being that if the distance is more than 10 miles, to show it on your answer sheet, you will have to select a large ratioed scale, maybe 1:5 or 1:10 or so. Now, as the scale becomes bigger and bigger, the errors in the plot get enhanced. If you have a scale of 1:10, then 1 centimeter is getting converted into 10 nautical mile. That means 1 millimeter on your plot is representing 1 nautical mile. Now 1 millimeter error on the plot is very much possible. The thickness of the pencil or the accuracy of your compass or divider can easily take you 1 or 2 millimeters up and down. And in that case, it will give you excessive error in your answers. So in case you have a distance more than 10 nautical miles, then the PL should be transferred by calculation and you should avoid doing it by plotting. So we will see that in the examples going ahead. Any doubts in these, beta?
सर ये कैलकुलेशन वाला अभी आप बताओगे ना सर आगे? How to do that?
I'll explain that to you, beta. I will show you a practical question where we will first do it by graphically plotting and then by calculation. I'll show that.
Okay, sir. Thank you.
Let me now briefly tell you about the steps which we follow in these type of questions. It is very important that when you start a plotting question, you understand the question well. Analyze the information, what is given to you in the question, understand it well, and once you understand the complete information, you can go ahead and make a rough diagram or rough plot. The rough diagram puts all the information in a pictorial form, in a picture in front of you, and it gives you a lead into how the question is to be solved. Now, once you have the rough diagram and you get a lead how the question is to be solved, you can go ahead and do the final plot. The final plot can be done now, and whatever calculations are required, they can be shown alongside the plotting. Always remember in these type of question that the question has to be solved first in your mind, and once you have clarity, then the question can be solved on the answer sheet. Great, beta. So these were the basic fundamentals which we use in plotting. Now I am taking you to some examples. Let us see some practical examples of plotting questions. I'm closing the presentation now. Now I'm going to show you these practical examples by way of a video. Okay, so let's see. Let me set up the video.
Let's apply our learnings to an example. In DR, 50 degrees 10 minutes south, 140 degrees 40 minutes east, star X observation gave an observed long 140 degrees 36 minutes east.
Beta, is the audio video both coming fine?
Yes, sir. This one is the simultaneous one, sir.
Yeah, this is simultaneous one.
Azimuth 075 degrees true. At the same time, star Y meridian altitude gave an observed latitude 50 degrees 14 minutes south. Find the vessel's position. Now, before we proceed any further, it's important to identify the methods deployed for solving the site of star X and star Y. I'm sure we can all figure out that star X has been solved using long by cron, and in such case, the PL shall be drawn through DR lat and observed long. Direction of the PL perpendicular to azimuth. As far as star Y is concerned, it's a meridian altitude observation. So the PL shall be drawn through observed lat and DR long, perpendicular to azimuth, but in this case of meridian altitude, the PL shall be specifically east-west, and hence it will coincide with the parallel of latitude of the observed lat. Now, having identified the processes deployed for solving the sites, we proceed ahead with the plotting. We have the DR lat coming up on the screen. We have the observed lat now the D lat from DR lat to observed lat is 4 minutes south. This information shall be used to plot these two parallels with respect to one another. Direction of PL of X, as already said, it will be perpendicular to 075 degrees true the azimuth, so shall be 165 degrees to 345 degrees. Direction of PL of Y shall be east-west, that is 090 degrees to 270 degrees true, being a meridian altitude observation and solved by latitude by meridian altitude.
Is it clear up to here, beta? Any doubts up to here?
No, sir. Yes.
Very good, beta. Great.
Now we come on this side. We have this DR latitude, the parallel coming out here. Then we decide on the scale that we would like to use. So we'll use, as far as graph in the background is concerned, one big box as 1 centimeter. If without graph, we can take 1 centimeter as 1 minute. So the observed lat has to be 4 minutes south of the DR. So we go 4 minutes south, D lat 4 minutes south, and we draw the observed parallel of latitude out here. Now, in this case, the latitude that the meridian that we shall need would be the observed long. So we draw the observed long. It's drawn out here. Now we all know that for star x, the PL shall be drawn through dr lat and observed long, that is this point. And direction as already calculated as 165 to 345. We have this PL for star x coming up here, passing through this point.
Okay, beta. So you see we have plotted our first position line. The longitude by chronometer PL is plotted. Have a good look. Let me know if any doubts are there in this PL, beta.
तो ये ऑब्जर्व लॉन्ग लेफ्ट में ईस्ट एंड राइट में बनेगा ना
You mean to say the DR longitude and observe
no
long?
observe long will be on the right of this thing नहीं ठीक है बेटा खाली एक ही लॉन्गिट्यूड ओके सर आई वाज कंफ्यूज
Okay. Actually, we do not need the DR longitude in this plot. Okay. So because we will not require it, so that's why it is not made.
yes sir understood sir.
Excuse me, sir. Excuse me, sir.
Go ahead.
Sir, can you explain this plotting, sir? Actually, I could not understand why they are taking only DR lat, then observe long, they are selecting. Why they are not choosing DR lat? Can you explain?
Okay. Okay, beta. Okay. So your doubt is why they have not used the DR longitude. Now, tell me, beta, the longitude by chronometer PL, it passes from a reference point. What is that reference point, beta? For long by chron?
Long by chron reference point will
DR lat observe long
DR lat and observe long.
Right. So we have shown only the items which are required to plot the PL. We have shown the DR lat also. You can see 50 degree 10 minutes south. And we have plotted the observed longitude also 140.36 east. And that is exactly from where the long bicron PL is passing.
Okay, sir.
Now they have given us the DR longitude in the question, but in this question we do not need the DR longitude to plot anything.
Okay, sir.
That's why we have not shown the DR longitude. If you want, you can show it also, but it will not be of any use.
Okay, sir.
क्लियर बेटा? और क्या डाउट आ रहा है?
सर ट्रैक्शन नहीं दे सकते अजमत सर?
You can show the azimuth also, beta. You can show the azimuth also in this.
Okay, sir.
Okay. Great. So first PL is plotted. Now let us plot the second PL. Second PL is simple. It is latitude by meridian altitude. So let's plot.
PL for star y is going to coincide with the observed parallel of latitude. So here is the PL for star y, which you can say should have been drawn through observed lat and dr long, but since it's east-west, so it doesn't matter whether dr long is marked or not. Now the two PLs being for the same time, they intersect here. So this becomes the fix of the vessel.
Okay, beta. So second PL is also there now. And the intersection point of both the PLs becomes the fix. Go ahead, beta.
Sir, this why are you taking observed long for the second PL, sir? We can take DR long also, correct?
No, beta. The second observation is meridian altitude observation. So meridian altitude observation, the PL is the observed latitude itself.
Yes, sir, I understood, sir. The observed latitude itself. I'm asking about the observed long. Why are you taking observed long and observed lat? We can take DR long and observed lat, correct?
DR long and observed latitude. You want to take DR longitude and you want to take observed lat, right?
So I'm asking, is that possible to take like that? If I'll get my answer correct?
No, beta. DR long is not a reference point to plot the long bicron PL.
But this is not longitudinal, no, sir. This is a meridian altitude, correct?
For plotting meridian altitude PL, that is the observed latitude, we do not require the longitude. Whether you plot the DR longitude here or not does not matter, beta. If you want, you can plot it also. The PL will remain like this only, whether you plot the DR longitude or you don't plot it.
But for calculating fix, we require to calculate departure. So we require some of the longitude for as a reference point.
For that, we have the observed long, beta. We can use that as our reference longitude.
Either one, observed long or DR long, either one we can take for as a reference point.
Yes, that's correct, beta. You can pick up any longitude in the plot as your reference longitude.
Okay, understood, sir. Only for calculating departure, we need this longitude. We can take a
That's right, beta. That's right.
And what do we see? The latitude of the fix is same as the observed lat, and this distance is the departure of the fix from the observed long. So we see that the departure is 1.1 minutes east from the observed long.
So you see, beta, we have taken the departure from the observed longitude.
So it should be from the DR longitude, right? Why it is from observed long, sir?
Okay, beta. If you want to take this from the DR longitude, that also can be taken. You can pick up any longitude of your choice as a reference longitude to get the departure.
Okay, sir. But the value will be different, right?
Obviously, beta, if you want to go to fix from 140.36, the departure will be something else. If you want to go to your fix from 140.40 east, the value has to be different. Na?
Yes, sir.
but the fix remains same.
Fix will remain the same, beta. Whichever reference longitude you take, the answer or the longitude or latitude of the fix will remain the same.
So we come this side
Understood.
for calculations now. Fixed lat is same as observed lat, 50 degrees 14 minutes south. Departure, read off from the plot using the same scale out here. From observed long to fix is 1.1 minutes east. We convert this departure into D long by using the cosine parallel sailing formula for latitude 50 degrees 14 minutes, and we get the D long as 1.7 minutes east. This D long we apply to the observed longitude, and that was 140 degrees 36 minutes east. When we apply a D long of 1.7 minutes east to it, our fixed longitude becomes 140 degrees 37.7 minutes east. So the coordinates of our fix obtained through plotting would be then 50 degrees 14 minutes south, 140 degrees 37.7 minutes east, and it's here that we have the fix of the vessel.
Oh, go ahead. Go ahead, beta. Any doubts, beta?
Yes, sir. Can you please just show a little bit for star Y, what will be the azimuth from where we draw the azimuth so that better understanding of this east-west line of PL?
Okay, beta. Star Y is on our meridian. So you see, it is mentioned in the question, star Y meridian altitude gave an observed latitude 5014 south. The azimuth is not given to us in the question, but when a body is on the meridian, the azimuth has to be either north or south. So it can be anything. It can be north also, it can be south also, but the direction of the PL for meridian altitude observation will always be east-west.
Okay, sir. And it will be from the observed long, 40 degrees, 140 degrees and 36 minutes east, correct, sir?
Longitude does not matter. You can draw the DR longitude also here. the PL will remain the same. It will be along the parallel of 50 degree 14 minutes south. Whether you show any longitude here or you do not show any longitude, it does not affect the second PL, the meridian altitude PL.
Okay, sir. Copy. Thank you.
Okay.
Yes,
We do not require a longitude to plot the meridian altitude PL. Meridian altitude PL is a simple latitude, parallel of latitude. You can plot it without any reference longitude.
Okay, sir. Thank you.
Go ahead, beta. Any more doubts?
Sir, if at all we take by mistake this DR longitude as a reference for this meridian, then it will be like 2.9 degree west. Or the departure will be 2.9 degree west, right, sir?
Departure is going to be, yeah, that's correct, beta. That is at 140.40.
Yes.
Right. So 2.9 degrees west. That's correct.
Okay. Anyhow, we will get the same answer only.
Yeah, answer will remain the same.
Okay, sir. Thank you.
Okay, great.
So if I use the DR longitude as a reference point to measure departure, so I will get a different final longitude, right?
No, beta. The final longitude is going to remain the same. Okay. Now, beta, just give me 1 minute. There is some requirement. Just give me a couple of minutes. I'll be back. Stay here.
Okay.
Okay, beta. I'm back. Go ahead with any more doubts if it is there, beta.
Sir, so if I take a DR longitude as a reference to measure departure, so then
Right.
I should be adding the departure to get the fix. So I will get the same, right?
Then you will be subtracting it, beta. The fix will be west of the DR longitude, na? So
yes,
that
yes, subtracting.
That's correct, beta. That's right.
Yes, sir. So you can use both ways.
Yes, you can use both ways.
Okay, sir.
Only thing is, if you plot the DR longitude here, it will become little lengthy. You will have to find out the departure between observed long and DR long, and you will have to plot it there. So that will only add a couple of minutes to the plot. That's it.
Okay, sir.
Okay, great.
I'll also take you quickly through same plot if it was done without a graph paper. It's the same plot, same steps. I don't think they need any further explanation because it's a repeat. But only thing is now the plot is being done on a plain sheet. And you can see how the plot is coming up. The two parallels have come up. We have the observed long meridian coming up. We have the PL for X. We have the PL for Y. We have the fix being identified here. We have the departure here. And then the same calculations as in the earlier discussion being carried out to get the coordinates of the fix. So if you do not have a graph paper, then your plot shall be somewhat like this. Please do not forget to declare your scale in the plot. It's very, very essential. So the whole idea of showing this one was that if you do not have access to the graph paper, you could have your plotting done this way, the way you see it on this particular slide, which is on display right now.
Clear, beta? Any doubts? Very good, beta. Great. So let's move on to the next question.
One more example. Using DR 12 degrees 20 minutes north, 180 degrees, simultaneous observations of two stars gave following results. Star X, azimuth 220 degrees true, observed long 179 degrees 55 minutes east. Star Y, azimuth 305 degrees true, intercept 3 miles towards. Find the vessel's position. I'm sure star X, which is a repeat as far as the process of deployed for solving is concerned, has been solved by Cron, as discussed in the previous case also. So therefore, for star X, the PL shall be drawn through dr lat and observed long. Direction of the PL shall be perpendicular to the azimuth. Star Y, which gives us intercept, has been then solved by intercept method. The PL shall be drawn through ITP, intercept terminal point or intercept terminus point, and the direction shall be perpendicular to azimuth. Having identified the methods deployed and the positions through which to draw the PL, we can proceed further. We can see on the graph, we have drawn dr lat and dr long and assumed a scale out here. Obviously, these have been placed keeping in mind the question so that other meridians and other parallels of latitude, if required to be plotted, they have enough space to be plotted on the graph. Now, dr long is 180 degrees. Observed long by solving star xi, it is 179.55 minutes east. So if I have to plot observed long with respect to dr long, which has already been plotted, then the d long between the two, it's the d long between the two, which is 5 minutes west from dr to observed long. That means observed long shall be plotted west of the dr long. But the spacing has to correspond to departure. So we find the corresponding departure, and the departure is found to be 4.9 minutes west. We also identify the direction of the PL for star X, which is perpendicular to its azimuth, direction being 130 to 310. And likewise, direction of PL of Y, perpendicular to azimuth of 305 degrees true, and direction being 035 degrees to 215 degrees true. So now using this departure between the two meridians, we plot the observed long. So here is the departure to the west, 4.9 miles, and here is the meridian for the observed long.
Any doubts up to here, beta?
सर इसमें डीआर लैट सर वो एंड सर ऑब्जर्वर से ले नहीं सकते क्या एक जगह से दोनों जो दो डिफरेंस किया गया 180 डिग्री माइनस 179 डिग्री 55 मिनट से कैन आई टेक द वन डीआर लैट एंड द वन ऑब्जर्वर लॉन्ग सर इट इज पॉसिबल
नहीं बेटा, with dr lat and observe long you will not be able to plot the intercept site because intercept requires the dr position. So for intercept we need dr lat and dr long combination also.
Okay, sir.
So why departure is between observed long and dr long? So it should be from the fix, right?
Okay, beta, we have first plotted the dr longitude in our diagram. Now we also want to plot the observed longitude in our diagram.
Yes,
the
sir.
east-west distance between them has to be the departure.
Yes,
So
sir.
to know at what distance should I plot my observed long from dr longitude, I have to calculate the departure, beta. Otherwise, how will I plot the observed longitude? How much distance away shall I go?
Okay, sir. Okay.
Okay, all right. Let's proceed ahead.
Now, wherever the dr lat intersects the observed long, this is the point through which the PL for star x has to be drawn, and its direction is 130 to 310. So here is the PL for star x, which comes up on the plot.
Okay. Any doubt in the long by Cron PL, beta?
No, sir.
Go ahead.
में अजीमथ जो लिया हुआ है 220 वो कहाँ पे प्लॉट करेंगे सर? इसका तो किया नहीं अभी कि स्टार एक्स का जो अजीमथ दिया 220।
बेटा आप चाहो तो एजीमुथ भी प्लॉट कर सकते हो। एजीमुथ अगर प्लॉट करेंगे तो वो dr lat और ऑब्जर्व लॉन्ग वाले पॉइंट पे प्लॉट होगा। सो dr lat और ऑब्जर्व लॉन्ग वाले पॉइंट पे आप 220 की डायरेक्शन में एजीमुथ भी प्लॉट कर सकते हो।
नहीं, लेकिन पीएल इनका इसी पॉइंट पे जाएगा सर, मतलब आपका डीआर लेट और जहां पे ऑब्जर्व लॉन्ग इंटरसेक्ट कर रहा है ना सर।
बेटा लॉन्ग बाय क्रोन का पीएल कहाँ से जाता है?
पीएल तो सर इसी पॉइंट से जाएगा, लेकिन जैसे डायरेक्शन अभी 220 है तो उससे 90 डिग्री पीएल होना चाहिए, ऐसा मतलब ईस्ट वेस्ट, उसके हिसाब से मैं पूछ रहा था सर।
बेटा आप चाहो तो यहाँ शो भी कर सकते हो। लेट मी शो यू हियर।
सर व्हाट इज द करेक्ट प्रोसीजर सर, वही मैं जानने का सर कोशिश कर रहे हैं अभी।
भाई एक मिनट, करेक्ट प्रोसीजर दोनों हैं। तुम अगर वहां पे एजीमुथ शो करना चाहते हो तो शो कर दो, तुम अगर एजीमुथ नहीं शो करना चाहते तो तुमने पीएल की डायरेक्शन निकाल दी बेटा। या तो तुम पीएल की डायरेक्शन ना निकालते, फिर तुम बोलते सर मैंने एजीमुथ प्लॉट किया, अब मैं उसके परपेंडिकुलर लाइन ड्रॉ करूंगा और वो मेरी पीएल बनेगी। तुमने तो प्लस माइनस 90 करके पीएल की डायरेक्शन ही निकाल दी ना, तो अब चाहे एजीमुथ दिखाओ चाहे ना दिखाओ क्या फर्क पड़ता है?
हाँ सर वही ना सर, एजीमुथ से लेंगे तो उसका पीएल डिफरेंट बनेगा, यहाँ से लेंगे तो उसका पीएल डिफरेंट आएगा सर।
पीएल डिफरेंट नहीं आएगा बेटा, पीएल तो सेम ही आएगा। लो मैं एजीमुथ बना के दिखा देता हूँ, एक मिनट रुको। 1 मिनट बेटा। बेटा azimuth, can you see the azimuth on the screen?
No, sir.
Is not yet? Okay. Give me a minute.
So we can snip that and then we can draw.
All right. Can you now see the azimuth on the screen?
Yes, sir.
Yes, sir.
Yes sir.
Very good. तो अगर आपका इतना ही दिल कर रहा है एजीमुथ बनाने का बेटा, तो एजीमुथ बना दो। यहाँ पे स्टार भी बना सकते हो, लेकिन पीएल यही रहेगी, तुम चाहे एजीमुथ बनाओ चाहे ना बनाओ।
यस सर। ओके सर, सॉरी।
अब मुझे बताओ क्या डाउट आ रहा है? और क्लियर है? ओके
Sir, excuse
गो अहेड बेटा।
Sir, in last question we are talking about whether we can plot this dr long. If at all we are plotting, then again we have to find its departure to plot, right?
So let's go, let's plot it बेटा। You are having this doubt again and again. Let's plot it. अभी plot कर देते हैं। Okay, where is dr long? 140 40 east. So let's plot it. 140 40 east. So you will have to first 140 40 east na, you will have to calculate the departure. This is 140 36. You will have to calculate the departure between 140 36 and 140 40. Okay, so whatever departure comes, keep that much distance here. This will be the departure. Okay, I have not calculated it yet. I am just making it as a rough diagram to show you, and you can mark this longitude here. Okay, this will be your dr longitude. If you want, you can show it here. There is no problem at all. What I am saying is there is no use of doing this exercise. It is just wasting a couple of minutes and it is not giving you any advantage at all.
We'll be wasting time for calculating departure and all on the...
Exactly, beta. You will be wasting time for calculating the departure, then for plotting this dr long, and it doesn't help your plot in any way.
But for the next question, we need to find departure first.
Naturally, beta. If you have a long bicron PL, you will have to plot observed long. If you have an intercept PL, you need a dr long.
Yes, sir.
So, any doubt in this, beta? Let me know. Dr long is there in the plot. See.
Clear, sir.
Very good. So it is clear finally. So we can remove the dr long now. Let's go back to our plot. So here we are. Our first PL is on the screen now. You want to have the azimuth now? ये लो azimuth भी बना दिया बेटा. ये रहा azimuth. If you want, you can make it. If you do not want to make it, it is perfectly all right, because you have shown the direction here. Direction of the PL is already calculated here, so you can directly plot it in this direction. Okay, but if it makes you comfortable, you can show the azimuth here also. There is no problem at all. Here it is. Okay, beta, clear? Great. Let's proceed ahead. Just a minute. Give me a minute.
Or star X, which comes up on the plot. PL for star Y would be drawn through ITP. So first we draw the azimuth through the DR. Azimuth of star Y has been drawn through the DR. Now intercept is 3 miles towards. That means it will be 3 miles on this line towards the body. We mark off 3 miles here. This green line showing up here measures 3 miles. So this is the point which is the ITP. Through this point, we draw perpendicular to the azimuth and we get the PL for star Y. Since both the PLs are for the same time, therefore this is where the fix is.
Okay, so we have the second PL now. The intersection point is identified as fix. So let me know your doubts up to here.
सर इसमें सर डीआर लैट एट डीआर लॉन्ग पर ही क्यों इंटरसेप्ट लिया गया सर?
Beta, go back to the intercept question. What is the reference point for
Yes.
drawing the intercept?
Yes. Remember.
है ना? Now,
Yes,
beta,
sir.
you have to be familiar with all the side solving methods and how they are plotted. I
Yeah.
did the plot for each and every method. So this
Yes,
simply
yes.
tells me that you are not clear about the plotting methods yet.
Yes.
Clear, beta?
Clear, sir.
So one doubt.
Go ahead.
So the length that we have taken for the intercept, that will be like we have taken 1 unit is equal to 1 mile. 1 box is equal to 1 mile. So
That's
we'll
correct.
take 3 lengths of this and then we'll mark the intercept point, correct?
That's correct, beta. This intercept will be 3 centimeters, which will be equal to 3 miles, because our scale is 1 centimeter is equal to 1 mile. So 3 boxes measured along the azimuth will take you to the ITP.
Understood, sir. Thank you.
Okay, great.
Sir, in the previous questions, cos mean lat we have used as observed lat, correct?
Yeah, that's right.
So we should not, cos mean lat mean we should be adding the 2 and by 2 we will get the mean lat, right?
Okay, beta. Now listen carefully, beta. When we are doing plane sailing calculation, the mean lat is the latitude of initial position and final position.
Okay, sir.
Correct? In the question which we did, let me go back to that plot. This was the plot. Our initial position the reference position which we have taken was on 5014. This was our reference position, beta.
Yes, sir.
And the final position fix is also on 5014. So the mean also will be 5014.
Okay, sir. Okay, sir. It's not difference between the DR and observed lat.
No, it is the difference between the starting position and the ending position. We have not considered 5010 in our calculation anywhere.
Okay, sir. Okay, sir. Understood, sir.
Okay. Now listen to one bonus point. Okay. The bonus point is, even if you take the mean of 5010 and 5014 and you put it here as 5012, cos of 5012, the numerical answer is going to still remain the same, because this much of a difference in latitude is not going to give you any practical difference in your answer. Okay.
Okay, sir.
So if any time you are doubtful which mean lat should I take whatever mean lat you think is most appropriate. Your answer will still be correct. Only thing is, don't show that mean lat here. Instead of showing 5014 here, just write cos of m lat and do the calculation. Your numerical answer will still be correct.
Okay, sir. Thank you, sir.
Okay, so that's a bonus.
Okay.
Okay, great. Going back to the question now, beta. This is where we are. Identified the fix.
Since both the PLs are for the same time, therefore this is where the fix is. We read off the D lat for the fix from the DR lat, which is 0.7 minutes south, and likewise we also read off departure, which is 0.8 minutes east of the observed long. Using this D lat and departure, we come on this side. We have the DR lat. We know the D lat of the fix from the DR lat, and we get the latitude of the fix as 12 degrees 19.3 minutes north. We have the departure of the fix from the observed long, which is 0.8 minutes east. We convert this departure into D long. So D long comes to 0.8 minutes east. So that means longitude of fix is 0.8 minutes east of the longitude, observed longitude. Observed longitude being 179 degrees 55 minutes east, the longitude of the fix is then 179 degrees 55.8 minutes east. And hence, the coordinates of the fix are 12 degrees 19.3 minutes north, 179 degrees 55.8 minutes east.
Okay, beta. So have a good look, beta, and let me know your doubts.
Clear, sir.
Okay, all right. Very good. Let's move ahead then.
Degrees 19.3 minutes north.
Now, one more thing here, beta. In case somebody wanted to take the reference of DR longitude here, okay? Somebody wanted to use DR longitude as its reference, you can use that also. Okay, that option is available to you. Now, if you use DR longitude as your reference, then in that case, the departure is going to be here like this. This is going to be the departure then. Right? So if you want, that also can be taken. It will give you a similar answer. And recommended is that you should take the reference from the nearest possible longitude and the nearest possible latitude. So that is the recommended one, because as the distance keeps on becoming bigger and bigger, the errors also gets amplified. So that is why we have taken the observed long as our reference longitude. Clear, beta?
Yes, sir. Understood.
Okay.
Yes, sir.
Right. Very good.
(179 degrees 55.8 minutes east). Now, if you do not have access to the graph paper, the same plot shall appear the way you can see on a plain sheet here. and drawn to a scale that is chosen, and that's how your plot shall appear on a sheet in the absence of being plotted on a graph paper.
Okay, all right. So this was our second question. Now, ready for the third one, beta, or you want to take a short break?
You can continue, sir.
Okay, all right, beta. Good.
Let's have one more example then. On 15th June 1992 at GMT 12 hours 05 minutes, the true altitude of the sun was found to be 89 degrees 55 minutes.
Okay, great. Now, beta, this question involves the concept of a high altitude observation. You see the altitude of the body is 89 degree 55 minutes. So have you done this high altitude observation in chart work?
No, sir.
Not done? Position circle में पक्का किया होगा बेटा. Center is the GP, radius is the TZD. Not done? Yeah, must have done beta. So anyway, I will revise that. I'll revise that once again. First, I'll tell you how a high altitude observation is to be plotted. So give me a minute. I'll first show you this. Before we go into this question, that understanding needs to be refreshed. Let's now try to understand what do we mean by a high altitude observation and how it is to be handled in the questions. If you find the altitude of any celestial body greater than 89 degrees in our questions, it is to be considered as a high altitude observation. Now, important thing to remember is that a high altitude observation gives us a position circle and not a position line. In normal celestial observations, we have 5 different methods: Marpas, long bichrone, intercept, X-meridian, Polaris. All of them, they provide us with position lines. But if you have a high altitude observation, that means the altitude is greater than 89 degrees in our questions, it will give us a position circle and not a position line. Now, when we get a position circle, the next question which arises is, what is the center and what is the radius of that position circle? These are the two things which we require to plot a position circle. So let us see what is the center and what is the radius of that position circle. The center of the position circle is given by geographical position of the body, also known as GP, Golf Papa, of the body. And the radius of the position circle is given by true zenith distance of the body, which is obtained by 90 degrees minus the true altitude. Now, the next question which arises is, how do we obtain the geographical position of the body? TZD can be easily obtained from the true altitude. How to obtain the geographical position of the body? Now, for the geographical position, we need to refer to the almanac and get the declination and GHA of the body. The latitude of the geographical position is equal to the declination of the celestial body. The magnitude as well as the name. Whatever is the magnitude and name of the declination, the same will be the magnitude and name of the latitude of the geographical position. The longitude of the celestial body is obtained, or longitude of the GP is obtained from its GHA. If the GHA is less than 180, then the longitude is named west and equal to the GHA. And if the GHA is greater than 180, then the longitude is named east and equal to 360 minus GHA. The reason for this is that GHA is measured from 000 degrees to 360 degrees, whereas longitude is measured only up to 180. Also, GHA is a westerly measurement. So if the GHA is less than 180, the longitude will be west. If the GHA goes more than 180, the longitude will be east. Clear beta, yaad aa gaya? Remember?
Yes, sir.
Okay,
Yes, sir.
all right, great. So now we can go back to that question. We will use this concept in that particular question beta. Let's go.
On 15th June 1992 at GMT 12 hours 05 minutes, the true altitude of the sun was found to be 89 degrees 55 minutes. At the same time, a point of land in position 23 degrees 26.5 minutes north, 001 degrees 15 minutes west, bore 320 degrees true. Find the position of the vessel if the sun passed north of the observer. Now in this case, the celestial observation shall not give us a PL because it's a high altitude observation with altitude of 89 degrees 55 minutes with a TZD is only 5 minutes. Therefore, in this case, the sun observation shall give us a position circle by the method that we have discussed in our earlier videos as PC by high altitude celestial observation. The second case is of a PL by bearing of a identifiable point on land, so that we are all conversant with. Now, first we need to get the GP of the sun to be able to get the PC, because when you have a PC by high altitude celestial observation, then the center of the PC is the geographical position of the body on the surface of the earth, and the radius of the PC is equal to TZD. And what is geographical position of a body? Geographical position of a body is linked to its declination. The latitude of the GP is same as the declination of the body, both in name and value and name. The longitude of the GP is related to the GHA of the body. If the GHA is less than 180 degrees, the longitude of the GP is same as the GHA, and the longitude carries a westerly name. If the GHA happens to be more than 180, then the longitude of the GP is 360 minus GHA, and the longitude shall be named east. We first be able to get the GP, we get the GHA of the sun, and we get its declination. So we have this as the GMT. From the almanac, we start getting the GHA and declination. Then we have the increment for GHA and decorrection for the declination. We get GHA of sun and we get declination of the sun. From here, what do we infer? That the GP's latitude shall be north 23 degrees 19.9 minutes, same as the declination of the sun. And as the GHA is less than 180, so the longitude of the GP shall be same as the GHA, and the longitude shall be named as west. So I hope you are able to recall how the GP is obtained.
Any doubt in the GP beta? Great, very good.
Now what we have drawn on the graph is the parallel of latitude for the land, the point on land, which is 23 degrees 26.5 minutes north. Why? Because we see that the GP latitude is south of it. Now this is here that we are drawing the meridian for the point on land, which is 001 degrees 15 minutes west, and we know the meridian of the GP shall be to the east of it because its westerly value is lesser.
So what we have done now beta, we have marked this land position. 23, 26.5 north parallel of latitude is shown. 001 degree 15 minute west longitude is shown. So land point is identified here. Any doubts up to here, beta?
Yes, sir.
Very good, beta. Great.
So that's why they have been drawn, one right on top almost and other to the left part of the page. Now we have this obviously is the landmass, the point on land whose bearing has been taken as to give us the second PL. Now we can, since the distances involved are little bigger, we can have a little smaller scale, 1 centimeter equal to 2 minutes or 2 miles. Now the land point to GP, D lat is 6.6 minutes south. That means the parallel of the GP shall be 6.6 minutes south of it. And since we have chosen this scale of 1 centimeter equal to 2 miles, so this is where we have the parallel of latitude for the GP of the sun. Now we find out the D long from the point on land, this meridian, to the meridian of the GP.
Beta, any doubt in plotting of this latitude, GP latitude?
सर लैंड पॉइंट लॉन्गिट्यूड का सर उसको सर थोड़ा सा एक्सप्लेन कर दीजिए सर.
Okay, what is the doubt, beta?
ये जीरो मतलब ये आपका जो लैंड पॉइंट का लॉन्गिट्यूड लिया था सर 01 डिग्री
Right.
15 मिनट वेस्ट सर.
Right, beta.
हाँ सर, इसका मतलब ये आपने लैंड का पोजीशन जो दिया हुआ था सेम वही लॉन्गिट्यूड प्लॉट किया है अपन.
हाँ बेटा, ये देखो राइट साइड में ये तो दे रखा है लैंड इन पोजीशन 23, 26.5 1 डिग्री 15 मिनट वेस्ट, यही हमने यहाँ पे बनाया बेटा.
ओके सर, ओके सर, थैंक यू.
ओके ओके.
And the D long is 7.4 minutes east. That means meridian of the GP on this would be on this side. But to space them out, we'll need the departure. So the departure using the latitude, we get departure at 6.8 minutes. So using the same scale of 1 centimeter is equal to 2 miles or 2 minutes, we come 6.8 miles to the east, minutes to the east, and we are able to plot the meridian of the GP. Where the meridian of the GP intersects the parallel of the GP, obviously this is the point where we have the GP of the sun.
So any doubts up to here, beta?
Sir, I don't understand, sir. Can you repeat again this after this D-lat?
Okay. Tell me, beta, what is that is not clear in your mind? Tell me.
Sir, we have plotted first the land position, then we have plotted the GP position, right?
Yes, right. That's right. Acha, beta, please mute your mics after you are done. Otherwise, your sound disturbs everybody in the class. Only the mic of the person asking the doubt should be open. Other mics should be muted. I take extra precaution so that you don't get any background noise from my side. So it's very irritating when you don't mute your mic. Now go ahead, beta.
So after plotting the land point, now when to plot the GP, lat and long, we need to convert that to departure, right?
Obviously, beta, any distances plotted in the east-west direction have to be the departure because we do not have any longitude scale in this plot. So we cannot plot the D long.
Okay, sir. For the latitude, we don't need to convert anything. Whatever is coming, we just have to directly plot.
Yeah, for the latitude, we require the latitude scale. And our scale which is there is the latitude scale only. The scale of distance is the scale of latitude. So that is available. So we do not need to convert latitude into any other thing.
Okay, sir. So far, we have plotted both the positions, not the fix. Okay, sir.
Right. We have plotted both the positions with respect to each other.
All right.
Okay.
Now we come to plotting of the PL and PCs. Now this is where we have the PL by bearing. This land point is bearing 320 degrees. So this becomes a PL of the vessel. Now we also know that the true altitude is 89 degrees 55 minutes. So TZD is only 5 minutes big.
Okay. So you see the first PL is plotted. This is basically the bearing of the land point. Now have a look at this PL beta. Any doubt, let me know.
So this PL you plotted using protractor.
That's correct, beta. It will be plotted using protractor.
Okay, sir.
Okay, great.
Which becomes the radius, 5 miles becomes the radius of the circle. So with this GP as the center and 5 miles as the radius, we draw the position circle, and this is the position circle of the vessel. Since this PC and the PL are for the same time, the vessel could be at the point of their intersection.
Okay. Now we have the position circle, the high altitude observation plotted on the screen. So any doubts in this?
So this position circle is cutting PL at 2 places.
Very good, beta. That's right. It is cutting at 2 places. So there is a possibility any one of them can be our position.
But the fix will be between position line and circle. So only one.
Fix has to be one only. Okay. So how will we decide which one is our fix? Is there anything which is given in the question to distinguish between the two?
Sun passed north of observer.
Very good. So where is sun in this diagram?
Okay, understood. Sun is north of observer.
Sun is
Okay, we have
GP,
G
so
should be
ऊपर वाला
north of okay.
Exactly.
First point.
The sun passed north of the observer. Sun is at the center of the position circle where the GP is. This is where the sun is.
Yes, understood. Thank you.
Sir, I still don't understand. Past north of observance, how do we locate, sir? Can you please explain?
Okay, try to listen, beta. I'm showing you here.
Vessel may be either at this point, that is point A, or maybe at this point, point B. Now, since the question says the sun passed north of the observer, now sun in this plot is represented by its GP. So if the observer is at A, then sun is passing south of the observer. But if the observer is at B, the sun is passing right north of it. So therefore, in this case, position A gets ruled out. The fix is then position B.
Did you understand that, beta?
Yes, sir. So GP is the celestial body, so it is passing north of the observer.
Yeah, that's correct. Right.
Okay.
So ये departure में cos 23 degree 23 minutes MLAT है ना sir, between 26.5 and 19.9.
Correct, beta. That's right. It is the MLAT.
मेरे को कुछ और आंसर आ रहा है सर.
What answer are you getting, beta?
Twenty-three. Okay. Sorry.
Clear? Okay.
Sir, one more thing, sir. In this case here, sun's GP, it is the position of the observer, that is latitude, longitude. Is the observer of the it is the position of the observer on the earth, correct, sir? On the
No,
land.
beta. No. Sun's GP is not the position of the observer. Sun's GP is basically representing the position of the sun on the surface of Earth. Okay. GP is basically a point which is representing the celestial body on the Earth's surface. Observer position is either at A or at B. Observer is not at GP. The celestial body is at GP.
Okay, then if the sun is north of the observer, means B will be the fix. Okay, okay, sir.
Exactly. B will be the fix. Then only sun will be north of you. If you are at A, the sun will be south of you.
Okay, sir. Okay.
Okay. All right.
So B is the fix out here. And what do we see in this case? That B lies on the same meridian as the meridian of the GP. So in this diagram, what do we see? This is the D-lat of the fix from the latitude of GP, and it's exactly 5 minutes south. So therefore, the latitude of the fix becomes 23 degrees 14.9 minutes north. What do we see about the departure? The fix lies on the meridian of sun's GP. So departure from there is 0, therefore D long is also 0, and therefore the fix long is same as the longitude of the GP of the sun, which is 001 degrees 07.6 minutes west. And therefore now the coordinates of the fix are 23 degrees 14.9 minutes north, 001 degrees 07.6 minutes west.
Any doubts in this now, beta?
So this type of questions can be asked in MMD for phase 1?
Certainly, beta. That's why we are doing them.
Okay, sir.
Yes, they do come. Okay.
So here in this case, we had the intersection of a PL and a PC. PL was drawn from a terrestrial reference and PC was by high altitude celestial observation. Just quickly a repeat of the same process on a plane sheet, same question. So just repeating it if you have to plot it on the plane sheet. Steps are exact repeat, difference being that instead of a graph, the plot is being carried out on a plane sheet and the plot shall appear the way it's coming up. We have position A and B coming up, and we have the fix also identified now, and it takes us to the position of the vessel. And this is how the plot shall appear if you do not have access to the graph paper. Then this.
Right, beta. Now, beta, if you do this question practically, your position will come slightly away from what is shown in the plot. There is a error in the plotting of this PL. So the position will come slightly east of this. Okay. So if you do it practically, don't get bothered. Your answers are going to be slightly different. Right, beta? Understood? Okay. All right, beta. Great. So these were simultaneous observations. So let's take a break now. Let's take a short 5 minutes break and then we come back. Okay, beta, are you back?
Yes, sir.
Okay, great. So let's move ahead now, beta. We saw some examples of simultaneous plots. Now I'm going to show you staggered plot. Okay. The first question which I'm showing you, see, I told you in the concept that if the distances are small, they can be plotted directly. The position lines can be transferred directly on the chart itself using the plotting tools. But if the distance is covered by the ship, in a staggered observation are huge, more than 10 nautical miles, in that case it is recommended to transfer the PL by calculation. So in this first question, I'm going to show you both the methods. First, we will do it by graphical plotting, and then we will do it by calculation, and we will see the advantage. Okay, beta? Okay, now this is just to emphasize the importance of calculation method. You are not required to do plotting in actual answers. Plotting is only being shown so that the concept becomes clear in your mind. So let me show you that. Okay, beta, are you back?
Yes, sir.
Okay, great. So let's move ahead now, beta. We saw some examples of simultaneous plots. Now I'm going to show you staggered plot. Okay. The first question which I'm showing you, see, I told you in the concept that if the distances are small, they can be plotted directly. The position lines can be transferred directly on the chart itself using the plotting tools. But if the distances covered by the ship in a staggered observation are huge, more than 10 nautical miles, in that case it is recommended to transfer the PL by calculation. So in this first question, I'm going to show you both the methods. First, we will do it by graphical plotting, and then we will do it by calculation, and we will see the advantage. Okay, beta? Okay, now this is just to emphasize the importance of calculation method. You are not required to do plotting in actual answers. Plotting is only being shown so that the concept becomes clear in your mind. So let me show you that.
Let us understand the full concept and the process through an example. In DR 50 degrees 10 minutes south, 140 degrees 40 minutes east, AM observation of star X gave an observed long of 140 degrees 36 minutes east, azimuth 075 degrees true. The vessel then steered a course of 120 degrees true for 100 miles when the latitude by meridian altitude of the sun at 11:55 ship's time gave an observed latitude of 51 degrees 10 minutes south. Find the vessel's position at 11:55 hours. I am pretty sure that if we were given a chart for this area, we could have easily transferred the AMPL to 11:55 and got the desired response. Now, in the absence of chart, let's try to create a small chart on our graph and do this question through an assumed scale. Now, in the morning side, obviously it has been solved by longitude by chronometer method. So the PL shall be drawn through DR lat and observed long. Direction of the PL perpendicular to azimuth shall be 165 degrees, 345 degrees. Why? Because the azimuth was 075 degrees true. Now, the morning DR lat is 50 degrees 10 minutes south. At 11:55, if you see the question, it has been solved by latitude by meridian altitude. So the observed lat is 51 degrees 10 minutes south, and we know that the direction of the PL in this case shall be east-west. So now we have D lat from DR lat to 11:55 observed lat, and the D lat is 60 minutes south. Direction of 11:55 PL, I've already said it's latitude by meridian altitude, so it's east-west. Now with this inference drawn out of the question, let's get going with the part plotting first. Here we have the DR lat 50.
Any doubt up to here, beta?
Sir, 100.
So this
100 miles
observed
are
on what is taken is not mentioned, right?
Say again, beta.
This initial AM site time is not mentioned, right?
Yeah, time is not mentioned. We do not need that also because they have directly given us the distance steamed.
Okay.
So distance is 100 miles. So anyways, we don't have to use the plotting method. Calculation ही करना है.
हाँ बेटा, कैलकुलेशन ही करना है, पर मैं प्लॉटिंग एक बार करके दिखा रहा हूँ ताकि आपको क्लियर हो जाए प्लॉटिंग क्यों नहीं करनी है.
Okay, sir.
Okay.
degrees 10 minutes south. We have the observed long 140 degrees 36 minutes east. So this is the point through which the AMPL shall be drawn. The direction of this AMPL is 165 345. That is the AMPL for star X.
So the AMPL is plotted, beta. Any doubt in this plotting?
No, sir.
Very good, beta. Great.
Now, we know that the DLAT from the DR lat to observed lat at 1155 is 60 minutes south. So we have taken a scale wherein one box here of 1 centimeter represents 10 miles. So that way we account for 60 minutes of DLAT, and we are able to then plot the observed lat for 1155. Now, the PL at 1155 is east-west, so it coincides with the observed lat, and here we have the PL for 1155.
Any doubts up to here, beta?
No, sir. No, sir.
Very good.
Now we have two PLs, one for the morning time, second for 1155. So to be able to deploy running fixed or staggered method, as we call it, we are calling it here now, we have to transfer this point, and we've learned that we transfer any point on the PL, first PL. And how do we transfer? We apply the run, we apply wind, we apply current, whatever is applicable in a given scenario. In this case, it's only the ship's own steaming. So point A is a point on the first PL. We draw the course of 120 degrees true, 200 miles, using the same scale which has been chosen here. And this takes us to point B. That means because of the ship steaming from morning side 1155, point A on the first PL gets transferred to point B. That means if I have to transfer this PL now, this morning PL, which is in the direction of 165 to 345, it can be drawn through B, and we get this 1155 transferred PL, which is the morning PL transferred to 1155.
Any doubts up to here, beta? Great, beta. Very good.
Transferred PLs are represented by two arrows at each ends. Celestial PLs are represented by single arrow at their ends. Once they are transferred, then they are represented by two arrows. So this transferred PL is for 1155. The second observed PL is for 1155. Needless to say, where they intersect, this becomes the fix of the vessel at 1155. Now, as far as the latitude of the fix is concerned, it's on the observed lat, so it is 51 degrees 10 minutes south. But this distance, east-west distance, we measure of the fix from observed long. We have done it in simultaneous plotting also. So this is the departure. So departure of the fix from observed longitude is 90 degrees east. We come on this side. Latitude of the fix is 51 degrees 50 minutes south. Departure from plot observed long to fix is 90 minutes east. We use this latitude to convert this departure into D long. We get a D long of 2 degrees 22 minutes east. We apply this d long to the observed long. Why? Because this departure was from the observed long, so d long shall also be from here. So we apply this d long and we get the fixed long as 142 degrees 58 minutes east. And this way we have been able to get the position at 11:55 a.m. through this plotting of the two PLs which were staggered, and we just transferred the first PL to get our fix. Okay, so this is what.
Okay. Any doubts up to here, beta? Before we proceed ahead?
This DLAT from the fix to where we have taken that to calculate the fixed lat?
Beta, we do not need any DLAT because the fix is exactly on the observed latitude. So its latitude is 5110.
Yes, sir. Thank you. Okay.
Okay, all right.
Sir, in the formula, d long equal to departure upon cos mlat. Cos
Right.
lat, lat is mlat, sir.
Yeah, that lat is M lat, beta. It is the mean of 5110 and 5010.
Okay.
Okay, great.
PLs which were staggered, and we just transferred the first PL to get our fix. Okay, so this is what we just solved. Do we see any problem with this working? Technically, none. But practically, yes. What is the issue here? Issue was that since the distances involved became larger, we had to compromise on this scale here. This scale, which in simultaneous plotting was 1 centimeter is equal to maybe 1 or 2 miles, had to be compromised to 1 centimeter representing 10 miles. That means the scale chosen had to be compromised upon. It became too small. The least count becomes small, and obviously the accuracy to read results also would then be compromised. So other than that, there is absolutely no problem whatsoever with this particular working. But then whatever is this limitation, it's also a serious limitation. The issue about this small scale can be resolved by reducing the scope of actual plotting and maybe performing part of the question numerically or mathematically on the answer sheet. What do we need here? We actually need to know the coordinates of point B through which the first PL has been transferred. So we could consider solving this part of the question mathematically by plane and parallel sailing so that we can get the coordinates of point B. Once we get the coordinates of point B mathematically, which means we get a point through which to draw the transferred PL, direction of the transferred PL shall be same as the direction of its PL in the morning, then that means we can now plot directly the transferred PL and we do not need to reference it to this point A out here. Why? Because all this has been mathematically then done. Once we have this point B coordinates through which to draw the transferred PL, we also have the second PL, transferred PL and second PL being of the same time, then this part of the plot, which is in the yellow box, can be plotted. And though you will be plotting a transferred PL and the second PL, but since they are for both same time, so the concept shall be exactly the same as you had done during the simultaneous observations.
Clear up to here, beta?
Sir, can you please start this part again, sir?
Okay, we will be doing this practically. So let me do it once again. Here it is.
By reducing the scope of actual plotting and maybe performing part of the question numerically or mathematically on the answer sheet. What do we need here? We actually need to know the coordinates of point B through which the first PL has been transferred. So we could consider solving this part of the question mathematically by plane and parallel sailing so that we can get the coordinates of point B. Once we get the coordinates of point B mathematically, which means we get a point through which to draw the transferred PL, direction of the transferred PL shall be same as the direction of its PL in the morning, then that means we can now plot directly the transferred PL and we do not need to reference it to this point A out here. Why? Because all this has been mathematically then done. Once we have this point B coordinates through which to draw the transferred PL, we also have the second PL, transferred PL and second PL being of the same time, then this part of the plot, which is in the yellow box, can be plotted. And though you will be plotting a transferred PL and the second PL, but since they are for both same time, so the concept shall be exactly the same as you had done during the simultaneous observations.
So is that clear now, beta?
Yes, sir.
Okay, all right. Let's do it now.
Same time. So the concept shall be exactly the same as you had done during the simultaneous observations. So now let's solve the first part of this question mathematically to get the coordinates of point B, and thereafter only do the plotting of the limited portion, that is the second part of it. We know that the course from A to B is 120
live class है वो भी आता हूँ
20 degrees true, which in quadrantal notation is south 60 degrees east, and the distance is 100 miles. Using the plane and parallel sailing formula, we get d lat from A to B as distance into cosine of course, which comes to 0 degrees 50 minutes south. Please do keep calculating if you have any doubt as the video is playing. Latitude of A is already known to us, that is the dr lat, and the d lat from A to B is 0 degrees 50 minutes south. So we apply this d lat to this one and we get the latitude of B as 51 degrees 00 minutes south.
Any doubts in the latitude calculation, beta?
No, sir.
Great.
You can also get the departure from A to B, that is distance into sine of course, and departure comes to 86.6 minutes east. Why east? Because our course in the quadrantal form was in the southeast quadrant, so d lat was south and departure is east. Now we can convert this departure into d long using the parallel sailing formula. D long will be equal to departure upon cos of lat or cos of m lat, depending on as the case may be, and we get D long as 136.4 minutes east, which translates to 2 degrees 16.4 minutes east. We know the longitude of A, which is same as the observed long, and we apply the D long to it and we get the longitude of B as 142 degrees 52.4 minutes east. So by applying the plane and parallel sailing formula, we have been able to get the coordinates of point B.
Any doubt up to here?
Sir, this east is given just because the longitude is east and course is southeasterly. That's the reason we got east on the D long.
That's right, beta. The course is southeasterly, so the D long will always be east.
Okay, sir.
So now point B coordinates are known. We know the direction of the P transferred PL, that has to be same as the morning PL, that is 165 to 345 degrees true. We know the second PL has to coincide with this parallel of latitude because its direction is east-west. So now we have two PLs, one drawn through this point B with the direction being 165 degrees to 345. Second one being drawn by latitude by meridian altitude method, direction being east-west. Now, having got
the same information is picked up here now, beta, and we are going to plot this now. It will be exactly like a simultaneous plot.
Sir, can you just show the last slide so that can take a screenshot?
Here it is.
Okay.
Okay.
second one being drawn by latitude by meridian altitude method, direction being east-west. Now, having got the point through which to draw the transferred PL, that is point B at 1155, and also having enough information to be able to plot the 1155 observed PL, we can now get the position at 1155. Now, DLAT from the latitude of point B, which is 51 degrees south, to observed lat, which is 51 degrees 10 minutes south, is 10 minutes south. And we now come to the plotting out here. We have the latitude of point B on the screen. Now we choose a scale of 1 centimeter representing only 2 miles. Remember, compare it to the, when we were plotting the full question, we had to compromise on the scale 1 centimeter representing 10 miles, which has now improved to just 2 miles. We have this as the longitude of B. Obviously, that gives us point B on the graph or the plot. Now, with respect to latitude of B, we draw the observed lat 10 miles south of it using the scale chosen. Now, through B, we draw the transferred PL, and transferred PL is for 1155 and represented by 2 arrows at each end being the transferred PL. We draw the 1155 PL by latitude by meridian altitude, and that comes up on the screen. You all know about it. And being celestial PL represented by single arrow at each end. Now, both these PLs are for the same time. So obviously now you know the procedure. This will be the fix of the vessel at 1155. Latitude is directly available on the plot. It's same as the observed lat. But we can also read off this departure from observed long to the fix. It's 2.7 minutes east. It can be much better read now with a better scale. And now we perform the same calculations as you would have performed in simultaneous observations. The calculations are coming up on the screen. You can see for yourself. We can convert the departure of 2.7 minutes into D long, apply it to the longitude of B, and what we get is the longitude of the fix. And this way, we are able to get 1155 hour coordinates for the vessel, which happen to be 51 degrees 10 minutes south, 142 degrees 56.7 minutes east. So now we can see that in case of staggered plotting, if the distances involved are large, if they are small, it can be graphically closed out. There's absolutely no problem. But if graphical representation is leading us to a compromise on scale, then that can definitely be avoided by performing part of the question mathematically and then only plotting the relevant part, wherein you deploy the same process as you have learned in the simultaneous observations.
Okay, beta. Go ahead with your doubts now, if any.
So we have used observed long. So in this case, we cannot use the DR long. It would be incorrect.
That's right, beta. For
So we have
transferring
it-
the PL, we need a point which is situated on the PL. So PL is passing from observed long. That's why we have to use the observed long.
Okay, sir. Understood.
So this was a staggered plot. So अब मुझे बताओ बेटा, you have the bandwidth of one more question, because with every question now a new concept will be coming in. So these questions are little tricky and complicated, the ones which are coming ahead now. So shall we stop here for today? Okay बेटा, simultaneous plot का एक और example आपको दिखा रहा हूँ. One more, have a look.
We quickly run through the last example. DR 00 degrees 4 minutes north, 179 degrees 57 minutes east. Two simultaneous observations, star X, azimuth 120 degrees true, observed longitude 179 degrees 58 minutes west, star Y azimuth 200 degrees true, intercept 2 miles away to find vessel's positions. I'm sure as far as methods are concerned, there is no discussion that should be required now. Star X by longitude by chronometer, star Y by intercept method. On the graph, you can see up dr lat and dr long coming up. And now to be able to draw the observed long with respect to dr long, we find the d long from dr to observed long coming up on the right side here, 5 minutes east. We convert this d long into departure, and departure also happens to be 5 minutes east. Then we identify the direction of the PLs perpendicular to their respective azimuths out here. And now with the departure being 5 minutes east with respect to dr long, we mark off the departure here, 5 minutes east, and we draw the meridian of the observed long.
So both the reference positions are plotted, beta. Any doubts up to here?
No doubt, sir.
Great.
Now to this point, which is intersection of dr lat with observed long, we have the PL for star X in the direction of 030 to 210, and you can see the PL of X coming up on the plot on the graph passing through this point. For PL of Y, we identify the ITP first. So we draw the azimuth of Y through the dr. Here is the azimuth in the direction of 200 degrees true. Now in this case, the intercept is 2 miles away. So we mark off 2 miles in the opposite direction, represented by this green line out here. So this is the ITP in the away scenario. Through this perpendicular to azimuth, we draw the PL, and this is the PL for Y. Where the two intersect, this point is the fix of the vessel. We read off its D lat. It's
Up to here, any doubt, beta?
No, sir.
Great.
0.3 minutes north of dr lat, and its departure we read off here. This departure is 0.2 minutes east of the observed long. We apply this d lat to the latitude of the dr lat, and we get the latitude of the fix as 00 degrees 04.3 minutes north. Departure from observed long to the fix is 0.2 minutes east. We convert this into d long, and being almost at equator, they are both equal. We apply this d long to the observed long, which is 179 degrees 58 minutes west, and we get the fixed long as 179 degrees 57.8 minutes west.
Okay, beta. Have a good look. Let me know any doubts coming in.
No doubt, sir.
Very good, beta. Great. So closing this now, beta. Okay. Now, beta, please practice these simultaneous plotting questions from the PracNav book. PracNav में आपको plotting की solved examples मिलेंगी. There are about 14-15 questions. 7 questions are there in simultaneous plot, then 7-8 questions are there in staggered plots. So first do all the questions of simultaneous plots. Okay, all the questions given in the book, simultaneous plots, practice them. After that, move on to staggered plot. We have done one question on staggered plotting. So move on to staggered plotting, whatever you can practice, great. And when you do staggered plotting, there are some more concepts which are required in these questions. So those concepts I'll be picking up in the next class. Okay. These concepts are transferring of position line in different scenarios. Then you have a concept of cocked hat, how to resolve a cocked hat, right? How to find the index error of the sextant, right? So these concepts will come, which we will do in the next class.
Okay, sir.
Right, beta?
Yes, sir.
Okay. So ये questions ऐसे हैं बेटा, please practice them well. Without practice, you are never going to get proficient in plotting. Up to here, side solving was okay. Even if you do a couple of questions, it's all fine. You can do it. It's just a application of the formula. But plotting questions are critical. Huh? So please practice all of them.